So a couple of things here first to note. One, whenever you're looking at a graph, always look at the axis. Very rarely, if ever, when we do these problems, especially with word problems, are you ever going to see X and Y? Very rarely. Because we're not talking about doing basic equations. We're talking about doing word problems. So when you start paying attention to the graphs, you want to look at the axis and see what it represents. In this case, we have time. In this case, we have distance. So in this example, it says the distance a delivery van is from the warehouse varies throughout the day. The graph shows the distance from the warehouse for a day from 8 a.m. to 5 p.m. So a couple of things that you should be able to read from this. Let's talk about our x-axis, which is our domain. Whenever we talk about the word domain, we're talking about the x values. So right here at the start, what would be the value that we would put there? Exactly. It's 0. Good job, Emma. It's 0. Now, that's not how it refers to it in the problem. It refers to the start of our day as what time? 8 a.m., okay? But as far as the amount of time that's transpired, 8 a.m. is equivalent to 0. We do our deliveries, do all that stuff. We come back to the warehouse at what time?
5 p.m.
We come back at 5 p.m., but that's not what would go right here. What should go right here on the x-axis? How long is it from 8 a.m. till noon? 4 hours. How long is it from noon to 5 p.m.? 5 hours. So overall, how many hours is that? 9. That's what would go right here. So one of the things that you guys need to be able to read and interpret is it's not a literal 8 a.m. on the graph and a 5 p.m. We're talking about the number of hours that those equate to. 0 is 8 a.m. 9 is 5 p.m. But we're talking about number of hours that transpire over that time, not the actual time of day. The next thing we talk about is the distance in miles from the warehouse. So some things to understand here. Anytime the line is going up, what does that mean about our distance? It's what? Positive, which means what about our distance, though? It's getting further away from the warehouse. Anytime our line starts going down, what is happening to our distance from the warehouse? We're going what? Back what? Be more specific. We're getting closer to the warehouse. We're going back towards the warehouse. Okay, so things to understand here. Going up is a positive slope. If it's positive, that means our distance is growing, increasing, getting higher. Those are terms that you're going to read in word problems that you need to understand. Okay, that means, in this case, our distance from the warehouse is getting bigger. If you're going down, decreasing, negative, then that means your distance is getting smaller, which means you're getting closer to the warehouse. Questions? So right here, we talked about how segment 1 is moving away, but segment 2 moves away just not as fast, at a slower pace. Question B, the change in distance. Segment 6, we just got through saying if it is going down, that means it's getting closer to the warehouse or it's going towards the warehouse.
Did you say it decreased?
So question C, which line segments show intervals where the distance did not change? What are segments in the graph where the distance from the warehouse did not change? Go ahead, Leo.
5.
Which one? 5 is 1.
7.
Okay, I heard somebody say 3. 5, and very good, 7. What is true about all those segments?
The race day.
Okay, but what about the lines? They're what?
Straight.
Okay, flat. Use a more technical term.
They're at a constant rate.
Starts with an H. They are horizontal lines, okay? All right, so for this one, it gives us an explanation of scenarios that are occurring, and it wants us to look and say, okay, which graphs correlate with these. It says 3 hoses fill 3 different water barrels. A green hose fills a water barrel at a constant rate. So if we read the word constant rate means it never ever what? It never changes. Constant means it stays the same the whole time. Which of those graphs shows water going into the barrel the same all the time? That is B. Okay? It is constant. It has a single slope, one slope. It goes in the same amount all the time. The second one, a black hose is slowly open when filling the barrel. So which one shows water slowly going in, but then increases very quickly? A. Okay, so the black hose would be A. We read the third one just to make sure. A blue hose, I should have used different colors for these. A blue hose is completely open at the beginning. So if it's completely open, what's happening? Water's going in a lot, and then what happens? It starts slowing down, which is C, because it goes in very, very fast, and then it starts flattening out here, because as you turn the water off, less water is going in each time. So it's being able to read a word sentence, interpret its meaning, and then match it with a graph. Okay, so question 3, which graph represents the situation where the ball gets stuck in the tree? Everybody should have put graph C. Because if it gets stuck in the tree, the ball goes up, but never comes back down. So the height just stays up there. Question 4, describe the height of the ball represented by the other 2 graphs. A is the one where he threw the ball directly at his partner, but he didn't catch it. So the ball never went up, he just threw it flat towards him, but the ball went down and hit the ground. So therefore the height had to be on the ground, which is this one here. The height is at 0, rolled towards him. The other situation was where he threw the ball up, and then it came back down, and his partner caught it. Now, here's a couple of questions. 1, why do the heights of all of these start above 0? Exactly. When a person is throwing it, they're not throwing it from the ground. They're not laying on the ground and throwing it. They're standing up. Okay? So, here's another question. Could you tell me a sport where possibly a height of a ball could start on the ground? Soccer. You kick a ball off the ground. What else? Huh? What? Football. If you're kicking the ball in football. Kickball. Golf. Okay. All right. Those are all situations where a ball could start on the ground and then the height go up. But if you're actually throwing, hitting a ball, something of that nature, then you're going to actually start above the ground, which is why each of these graphs, the height is not at 0. So one other thing to point out, in the graphs we've done thus far, what quadrant have all these graphs been in? First quadrant. What can you tell me about all the values in the first quadrant? They're all positive. This goes back to something we pointed out a long time ago, which is anytime you're graphing a word problem, almost always you're going to graph it just in the positive quadrant. Are there things that can be negative?
Yeah.
Such as money. That means you what? Owe money. You're in debt. What else?
Like the level of like a lake or something.
Okay, sea level. You could be above or below sea level, so you could be negative. What else can be negative? Okay, scores in golf could be negative.
How about,
You can go backward. I just, oh, no.
How about temperature?
Yes.
Okay, temperature could be negative. So one of the things here we need to learn is a continuous graph and a discrete graph. Practically everything you guys have done, probably up to this point, has been a continuous graph. All a continuous graph is that you can write a smooth, connected line or curve. A discrete graph are individual or independent points. They have a pattern, whether they go up, go down, stay the same. The problem is they are not connected. So certain things that occur here, in this particular example that they're using, they talk about the number of problems on a test that are answered correctly. Well, if I answer one problem correctly, then I get 10 points credit. If I answer 2 problems correctly, then I make a 20 on the test. So if there are 10 problems on the test at 10 points each, then I make 100. Why do I not have a point in between these two?
because they're each worth 10 points.
Because each problem is 10 points. So if I'm looking right here, what problem number am I talking about?
One.
I'm talking about problem 0.5. Is there a 0.5 problem? No. Okay. It's problem 1, problem 2, problem 3, problem 4. That is a discrete function. You can't have fractions. You can't have what else? Decimals. Okay. They're whole units, individual, distinct points. That is a discrete function. That is a discrete function. So again, anytime we're talking about domain and range, we're talking about X and Y. Before we even do that, the first thing I'm going to do is actually graph this problem. It is super important that you graph it as you read the problem. So the first thing I read, a bathtub is being filled with water. After 10 minutes, there are 75 quarts of water in the tub. So the first thing I do is I go to where 10 minutes is, I go up to 75, and I put a point. Now, things that might help you here. The scale is something you have to pay attention to for every problem. On the bottom, my X's are all going by 5s. Something you may need to do for these is go through and actually write these in to help you read it and interpret where the numbers are and be able to plot them. So again, middle school, you may have been doing a scale of 1 every time. Not going to be the case in here. I look at my y-axis. Can somebody look at the y-axis and tell me the scale? Very good. They're going by 15s. So it's 15. If you add 15 to 30, you get to 45. If you add 15 to 60, you get 75, which is why I put my point there. 15 to 90 is 105. So something you may have to do to help yourself is go through and write those in, fill those in to help you so as you plot the point. Okay, next thing. I read the next sentence. Someone accidentally pulls the drain plug while the water is still running and the tub begins to empty. The tub loses 15 quarts in 5 minutes. So I need to represent that with a point. So I go back to the graph. I was at 10 minutes. 5 minutes later, which puts me at 15 minutes, I have lost 15 quarts. So what's that mean about my point now? It goes from 75 to where? Down to 60. Very good. So I put a point here. So the first 10 minutes, it filled up and went to 75. Now, let me ask you this. Is this a discrete or continuous function? Is water always going in, or I'm just pouring water in at points? Water's always flowing into the tub. That makes this a continuous function. Water is always going in. It just goes in from here up to here. Then what happened? Water started going out of the tub, so it starts going down. So here, it's gaining water, and then it said we lose water. Terminology again, positive, negative slope. At that point, it says someone plugs the drain and the tub fills for 6 more minutes. So I'm at 15, so where is this going to take me now? I'm at 15 minutes for this point. Tub fills for 6 more minutes, so now I'm going to be at 21, so just past 20. Gaining another 45 quarts of water. So I go to 21 and then put a point where?
At 105.
At 105, because I went from 60 up to 105. So again, here my line is going up because I was gaining water. Next it says, after a 15-minute bath. So when I start actually taking my bath, what am I no longer doing? Probably.
Filling it up.
I'm probably putting no more water in it. So what's that mean about the amount of water that's in here? It's the same. For how long?
For 15 minutes.
15 minutes. So I need to go here. I need to draw a what kind of line? Horizontal line, basically to 30 what? Okay, just past 35, 36, because remember we were at 21 plus 15, so just past 35. Then it says it takes 11 minutes for the tub to drain. So now that's going to put me from 36 to where? To 47 minutes, and the amount of water is going to go from 105 down to 0. So I go from here, 47, be just past 45 here, and now I have 0. Now, doing the graph is a whole lot easier to help you answer the next questions. The graph is what kind of graph? It's a continuous graph. It keeps going the whole time. We keep putting water in and losing water continuously. The domain is our x. So we can just look at the graph and say, where did our x start from? 0. So x is greater than or equal to 0. What's it less than or equal to? Where did our x go from? 0 to what? Where is this again? 47. Now, 47 was never mentioned in the word problem. We came up with 47 based on the information. 10 minutes of water going. 5 minutes of losing water. 6 minutes of adding water. 15-minute bath. 11 minutes of draining. You have to come up with that. It's not directly in there. The range is our y value. What is our y between? What's it greater than or equal to? 0. The y starts again at 0. What's our y go up to? 105. 105 is the highest the y value makes it to.